Okay, students, go ahead and go over some of these problems here. Secant angles, they're including chords into here. Because technically, I guess if the way I'm looking at it is that if I was to extend this out, it would be a secant, and that would be a secant. Okay, and so they're calling those secant angles as well. So if I want the question mark and angle P, which are obviously vertical angles, they're equal, I add the two intercepted arcs together and then divide by 2. That's simple. 175 plus 55 is 230. And I divide by 2, 115. Okay, so that's what you'll do with any of those ones. Here we have two secants. And again, it is the outer arc minus the inner arc. Also, you could consider the big arc minus the small arc. Okay, which is what it says, big arc minus small arc equals 2 times the measure of angle R in this case. So big arc minus small arc, 140 minus 50 equals 2. If I want to just call that x for the angle, just make it 2x. So I get 90 equals 2x, and therefore divide by 2, and I get x equals 45. So the angle, which we just renamed it as angle, measure of angle R, we just change it to x. So the measure of angle R is 45 degrees. Okay. You should already know from inscribed angles, and they're calling this, again, chords like this, secants for a reason, but it's an inscribed angle, we know it's half of it. So you have all those. Okay, so that takes care of the top section here. Same idea down here. Okay, now they're just dealing with algebraic expressions, but it's the exact same idea. I double that 70, that has to equal the arc measure right there. So 140 equals that. Okay. Double the inscribed angle equals the arc. All right, here, again, it's just like up there, outer arc or big arc minus small arc equals double the angle, and the angle is 50, so it equal 100 then. Solve it. Okay, next page. Here we have more of the same. Okay, right there. Let's go down to here now. Find the measure of the arc or angle. Again, we have an inscribed angle. This 5x minus 1 would be this angle right here. I just can't make it that small, but that's where it's supposed to be. So again, if I double that, that would equal the arc measure right there, 8x plus 14. Okay, that's just a degree sign. Okay, so again, we add the two arcs together, divide by 2, and it's going to equal 26 minus x minus 2 and solve it. Okay, that's all the same. Let's go to the next type, segment lengths. So those are angle measures. Now we're dealing with segment lengths. Remember, anytime we have a tangent, anything that appears to be a tangent is a tangent. Anytime we have a tangent, or a tangent only touches the circle in one spot, even if I extended it through, it would only be hitting one time. Whenever we have a tangent, it's tangent squared every time. And then every time it's a secant, it's the outer times the whole segment. Outer segment times the whole segment. Okay, so in this case, we have 15 squared. For the tangent squared equals the outer, which is 9, times the whole. The whole would be 9 plus x. Not 9 times x, which is a common error. You're not multiplying two segments together, you're adding them together. 9 plus x. Okay, and then you go ahead and solve that. So again, down here, 3, we have outer 4 times the whole thing, which would be 4 plus x minus 3, equals 5 times the whole thing of 5 plus x minus 6. Okay, so you're doing that over and over here. All right, when it comes down to here, in 5 and 6, for example, when I have two chords that intersect, I just multiply the individual pieces. 4 times x must equal the other pieces of the other chord. 5 times 8. Okay, then I would solve it by dividing by 4, leaving it like this. And the 8 cancels the 4 2 times. 2 times 5 is 10. Notice I'm not multiplying out the 5 times 8. So I'm going to just cancel it, deal with smaller numbers. Shortcuts. All right. So again, that's the same. Let's turn to the next page here. Okay, again, more of the same, except for with algebraic expressions now. Multiply the two pieces together equals the other two pieces of the chord together. Here again, same idea. We have two secants, so the outer times the whole segment equals the outer times its whole segment. Make sure you add the segments together when you put the whole segment together. Okay, same idea here. Again, more just algebraic expressions. Okay, all that's the same. Now don't forget, when I have a tangent here, I'm squaring it, so it's going to be x plus 8 quantity squared now. Okay, so you have a quadratic involved there, just like you have a quadratic here, because you have 6x times 12x would be 72x squared equals 8 times 9, which is 72. So the whole thing cancels out. And I get x squared equals 1. So x would equal plus or minus 1. Because remember, that tells me there's two answers from algebra 1. But of course, I can't have a negative length, negative x. I make it negative 12, negative 6. So I only take the positive answer. So x equals 1. And as we've talked about before, x equaling negative 1 is called an extraneous solution, or extra. You write out the word extraneous. And obviously, you see the key word there is extra. So remember this for algebra 2. When you talk about it, you're going to have algebra extraneous solutions in algebra 2 as well. Okay, that looks like that was it. That was page 6 then. Okay, that'll go ahead and end it right there. So now it's a good review of the other worksheets that we've done already. Okay, putting it all together. The only thing this does not include is our first two sections, which is completing the square to write the standard form equation of a circle, or given the standard form, identifying the center and the radius, graphing the circles given the standard form, or if you had to complete the square first. And obviously, if you were given a center and a point on the circle, you'd have to find the radius first and write the equation. Or if you're given the diameter, find the midpoint, use the midpoint formula to find the center of the circle, so you can plug it in standard form. So that's the only thing that's not covered here. Otherwise, everything is covered. And I might add one more section on that's not covered in here. I'm still waiting on that, if I add that in there. Otherwise, we would be done with the circles unit. All right, that's it.